Multiplying and dividing rational expressions. So before we multiply rational expressions, let's talk about how to multiply regular fractions together. So when you multiply, remember that you simply multiply numerators and denominators individually. So we would really have 2 times 8 over 3 times 5. Now it's easiest if you try to simplify at this step. However, 2 has no common factors with 3 and 5, and same thing with 8 and 3 and 5. So we have to just keep multiplying. 2 times 8 makes 16, 3 times 5 makes 15, and this is as simple as this fraction becomes. Now, if there's a whole number, remember to divide this by 1, and so we really have 9 times 4 over 1 times 6. 9 times 4 over 1 times 6. However, I do know that 6 factors into 2 times 3, and I know that 9 factors into 3 times 3. So what we really have is I can really cancel out or simplify the 3 and the 3. That common factor I can simplify out. So now we have 3 times 4 over 1 times 2, a lot simpler to work with. But I see now that I can change 4 and 2. I know 4 is 2 times 2, and 2 is, I can cancel one of those out, simplify it down. So 3 times 2 is 6 over 1. Now, I did it that long way on purpose because it makes a little more sense when we get down on this rational expressions part. When you divide, so there's kind of a little trick to help you divide fractions. It's called keep, change, flip. Or some teachers, you might have learned it as KFC, keep, flip, and change. Either way, it's the same thing. The first fraction stays the same. Then you change this division to multiplication and you flip the second fraction. So now we have a multiplication problem, which is a lot easier to do. 3 times 8 makes 24. 6 times 4 makes 24. And 24 divided by itself is 1. Same thing with a whole number. This is 2 over 1. So 2 over 1 stays. Change the division to multiplication and flip 5/3 or 3/5 into 5/3. And then multiply. 2 times 5 makes 10, and 1 times 3 makes 3. Now that we've done that, let's look at some actual rational functions. So there's basically 3 basic steps. Factor the numerator and denominator, and then divide out any common factors that you can. So simplifying rational expressions means we don't have a multiply or a divide operator. It just is a single rational function by itself. And so when we simplify, we're going to factor everything that we can. So let's first look at the numerator on example 1. So x squared minus 4x minus 12. So we need 2 numbers that multiply to negative 12, but add up to be negative 4. And so we can do that by negative 6 times 2. So break apart b, so that makes negative 6x plus 2x minus 12. Take out common factors from the first two, so factor by grouping. X is common, so I can divide out x, and I'm left with x minus 6. On the last two terms, I can divide out a 2, and I'm left with x minus 6. So my final factored form would be x minus 6 times x plus 2. So that's my new numerator. So we'll hold on to that. Now let's look at the denominator. So x squared minus 4. Well, I know that this is that difference of squares. So the difference of squares factors very quickly. The square root of the first one, so the square root of x squared is x, plus the square root of 4, which is 2, times x minus 2. So the same factor, one positive, one negative. Now that both numerator and denominator have been factored, put it all back together. So the numerator is now x minus 6 times x plus 2. That's your new numerator. Over the new denominator is x plus 2 times x minus 2. So when we are multiplying, remember that anything divided by itself is a 1. So I'm going to show you the long way about this. Let me show you what's actually happening in the math background. The reason why we say x plus 2 and x plus 2 cancels is because of this. I can rewrite this as x plus 2. Actually, we'll move some stuff around here for just a second. Let me move this guy over. Okay, so I can rewrite this as x plus 2 over x plus 2, the same factor, times what's not the same. So x minus 6 over x minus 2. And we all know that something divided by itself is really just 1. So what we really have is 1 times x minus 6 times x over x minus 2. Well, 1 times anything is still just that thing, which is why it's easier for us to say that the x plus 2 cancels, but this is really the math that's happening behind the scenes. X plus 2 divided by itself is simply a 1, and if I do 1 times anything, it's just whatever's left over. Now, I want you to try example 2. We don't need to go through all of this process. Simply factor and then divide out any common factors. Pause the video, try number 2. And here's your solution for example 2. Now, let's actually start multiplying rational expressions together. So the first thing we need to do is factor numerator and denominator. So we're going to be doing a lot of factoring. Divide out any common terms across the entire multiplied expression. And the reason why we're allowed to do that is because remember, when you multiply fractions together, their numerators are multiplied and so are their denominators. Multiply any remaining factors and then write in simplified form. Most of the time, we don't really need to do step 3. Most of the time, if you leave it in factored form, you're doing just fine. So let's look at example 3. So for example 3, it's kind of hard to factor this because the numerators and denominators are one term. So I'm not really factoring as far as the AC method or by grouping or even like difference of cubes, difference of squares, things like that. We're really just using exponent rules. So I'm going to simplify this first fraction on the left. I know that 8 divided by 2, I can make that 4 over 1. If I have 3 x's in the numerator and I divide out an x, I'm left with 2 x's in the numerator, so x squared. If I have y and I divide out y squared, well, one of those y's are going to simplify out, and we're just left with y. Subtract their exponents. Times, well, 7 divided by 4, I can't do anything with that. X to the fourth, there are no x's in the denominator, so we're just going to leave it as x to the fourth. But I do see I have y to the third divided by y, and so that leaves me with y squared in the numerator. So now we can multiply the two fractions. So multiply the numerators and their denominators. But I do know that 4 divided by 4 is 1. And I know that if I have y squared and I divide out a y, we're simply left with 1y on top. So this squared and this y will divide out. X squared times x to the fourth is actually x to the sixth. And then 7 is on the top, and this is all divided by 1. So it's simply just 7x to the sixth y. Use your exponent rules to simplify something that only really has one term all the way across. Let's look at example 4. That's more of like what you're going to be seeing. So we're going to multiply these together. So for the numerator here on this first fraction, it's very simple. We're simply dividing out a common factor. So for the numerator, we're going to have 3 times x. So for the GCF on the numerator, our GCF is 3 and x. So if I divide out 3x, I'm simply left with 1 minus x. Over on the denominator, x squared plus 4x minus 5. Hopefully by now you've kind of seen a pattern with this. If your a value is 1, your factoring is very easy to do. X and x. So I need numbers that multiply to negative 5 but add to a 4. So that means I have positive 5 and negative 1 as my factors. So x plus 5 times x minus 1. Times, let's look at the right side. Again, I have an a value of 1, so this will be a very simple factoring. So again, it'll factor out like this. It has an x and an x. So I need numbers that multiply to negative 20, but add to a positive 1. So again, that's positive 5 and negative 4. So this factors out into x plus 5 times x minus 4. Now, 3x cannot be factored, so we're going to leave 3x just the way he is. Now let's look for some common factors to divide out now that everything has been factored. So x plus 5 has x plus 5 in the denominator, so that simplifies out to a 1. 3x and 3x simplifies out to a 1. Now, these are almost the same. You need to be careful with that. The x is in different places. So really what we have in the numerator is we have negative x plus 1. So we have negative x plus 1 in the numerator over x minus 1 times x minus 4 over 1. So what I can do with this is I can actually factor out this -1 here, and maybe I can see if I can cancel something else. So negative times x minus 1 over x minus 1. Now that I have factored out a -1, now these are the same and I can divide those out. So we have -1 times x minus 4. So -1 times x minus 4 all over 1, which you don't really need. So let's distribute out this -1 just to make it a little bit nicer. So this simplifies down into -x plus 4. For example 5, what we're going to do with this one is remember that this is actually a whole number. So all of this is really over 1. So we need to factor out the numerator and the denominator for both fractions. So I want you to pause the video and factor this out. Keep in mind, this denominator will actually use difference of cubes. So please remember the rule for difference of cubes. Pause the video and try to factor number 5 and simplify as far as you can. And here's your solution for example 5. X squared plus 3x plus 9 does not factor. There is no number that multiplies to 9 but adds to a 3. And if I look, when I do difference of cubes, I actually end up with x squared plus 3x plus 9 in the denominator of a multiplied fraction. So that means I can simplify this fraction out into a 1. And all we're left with is x plus 2 over x minus 3, because if you multiply by 1, nothing changes. So I want you to pause the video and I want you to try example 6 on your own. And here's your solution for example 6. Take out an x from the numerator, factor the numerator on the other fraction into x plus 3 times x minus 2, and we see that this x and this x simplify out, this x minus 2 and this x minus 2 simplify out. Now let's talk about division. So dividing really is exactly the same as multiplying, except for one tiny little thing in the beginning. We have to do that keep, change, flip, and change this into a multiplication problem. So before we even begin, let's change this division into multiplication. So we have 2xyz over x to the third, z to the third. Keep the first fraction, change the division to multiplication, and flip the second fraction over itself. So now we have 2x squared z squared in the numerator over 6y to the fourth in the denominator. And now that this is a multiplication problem, it looks very similar to this example number 3 we had at the very beginning of our multiplication section. So I want you to pause the video and try example 7 on your own. And here's your solution for example 7. Let's look at example 8 together, and then I will have you guys do 9 and 10 if you need some more examples. So find the quotient of, so quotient just means division, 7x over 2x minus 10 divided by x squared minus 6x over x squared minus 11x plus 30. So first with division problems, we need to change them into multiplication problems because we're only allowed to simplify with multiplication, not division. So we need to keep the first fraction the same. So 7x over 2x minus 10, change the division to multiplication, and flip the second fraction. So this is really x squared minus 11x plus 30 over x squared minus 6x. Now that it's a multiplication problem, we follow the exact same steps we did at the start of the notes. Factor everything. 7x cannot be factored. The denominator I can divide out a 2 and you're left with x minus 5. Times, so this numerator, so I need two numbers that multiply to 30 but add to -11. So that would be -5 times -6. So one factor is x minus 5 and the other factor is x minus 6. In the denominator, I can factor out an x and I'm left with x minus 6. So now that we have everything factored, let's see if we can simplify out some common factors. So I see x minus 6 and x minus 6. I also see x minus 5 and x minus 5. And there's even one more. Here's an x and here's an x. These are being multiplied together. So I can simplify x over x as well. So all we have left is the 7 in the numerator over the 2 in the denominator. So this actually simplified out to a rational number without variables. So now I want you to pause the video and I want you to try 9 and 10 if you need some more examples. I'm going to Work it out and then unpause and check your answers as you go. And here's your solution for number 9. Pause the video again and try number 10. And here's your solution for number 10.